Genesis Systems builds robotic welding systems. That's our primary business, but we try to look not only at the arc welding process itself, but also the operations that are in front of the arc welding cell and then subsequent operations also.
When Genesis Systems Group was approached by American Axle and Manufacturing, or AAM, the company was in search of a solution. AAM is a world leader in the manufacture, engineering, design and validation of driveline systems, chassis systems, and forged products and services for passenger cars, light to heavy trucks, buses, and sport utility vehicles. A large portion of its business involves the design and manufacture of driveline systems for these vehicles. Enter Genesis Systems Group.
When the client came to us, they were looking for someone that they could partner with to kind of expand the boundaries of the typical equipment transaction. They wanted someone who could help with the lead engineering and design for manufacturing issues on their component, and who would stay with the transaction until the initial production launch was completed and the equipment was demonstrated reliable in production.
Genesis Systems Group began as the service wing of a major regional industrial equipment and supply operation serving Midwest metal fabricators. Today, Genesis designs, integrates, builds, and installs flexible automation systems around the world. They are the single largest independent robotic system builder for arc welding in North America. But Genesis doesn't want you to think that all they do is sell robots.
When our client approached us, the needs they had were, similar to most of the new product applications that we run into. They have a new product, it's a new design, perhaps they're working with some new suppliers, and at that point there's really some unknowns. And there's meant to be unknowns. You have a part design that's on a piece of paper, and there's tolerances associated with it, and really at that point the issues that need to be looked at are how do the simple parts get processed in their original format, and what are the capabilities of those processes, and how do they impact the overall assembly in its welded form. So those were really the things we concentrated with up front.
There were actually three separate and critical criteria that the client needed to accomplish. The first one was the metrics on the component itself. There were 13 critical dimensions on the axle assembly that had to be held within very tight tolerances, and it's a complex assembly. The second set of criteria had to do with the weld characteristics themselves. The weld had to have certain levels of penetration, certain lengths, certain profile that were deemed acceptable for the product. And the third criteria was that the equipment had to deliver the welds and the dimensionally correct components in a certain cycle time and with a certain uptime so that they could meet their production requirements.
When Genesis decided to take on their client's project, the first step they took was to look at a computer-simulated run of their current system. The computer process, called Variation Simulation Analysis, or VSA, provides a simulated model of how variance of components affect overall dimensions of the assembly.
One of the early conclusions from the VSA modeling was that in order to achieve the dimensional outcomes they were looking for, they would have to change some of the simple part processing methods. When the simple parts are created, there are certain measurements that have to be held within certain tolerances, and some of those had to be tightened up, or they simply would not be able to produce the final assembly to correct tolerances.
AAM and Genesis began working with Casey Welding and Fetz Engineering to develop a process to achieve maximum performance. Casey Welding provided process development and weld validation input. The company also helped identify welding concerns that needed to be addressed in the real-world production environment.
Casey Welding was doing the prototyping or pre-production work to develop the axle, and as such they had rather intimate knowledge of some of the challenges that they were going to have putting the axle together. As such, we were able to work with KC to affirm the output of our VSA modeling and also to point out some other areas that may need to be addressed in the final solution.
Fetz Engineering specializes in dimensional engineering, assisting with part design and weld fixture dimensional control.
Ultimately, once you make all the decisions of how to control the simple components and control the final assembly, you need to design and manufacture a tool that holds those components while it's welded. FETS Engineering provided the service of developing the tool control plan and the tooling to help us embody the final assembly in the optimal method that we had discovered.
Together, the partners met with the component suppliers, stampers, and bracket manufacturers to verify their capability to produce the simple components. To maximize uptime of the machines, AAM wanted to avoid a line type of system. Line systems are especially sensitive to routine production disruptions, which in turn disrupts the entire process. The decision was made to decouple the process, allowing single systems to function independently of each other.
One of the older manufacturing methods that many of our clients use is referred to as linear processing, where basically they'll take a component and they will move it from process to process automatically. And as such, the processes are intimately and critically coupled. So if any process goes down, they're all down because they're waiting on the component that's ahead of them or behind them. Or if something happens with the handling systems, all processes are down. One of the things that we do and recommended to this client was to not do the linear processing on this, but to do cellular or decoupled processing so that each operation can perform independently, and that's a good way to optimize uptime. And with linear processing, it's not unusual to have uptimes as low as 60%, whereas with decoupled processes, it's not unusual to have uptimes in excess of 97 or 98%. So you can actually do the same job with less equipment and less people.
Operations were designed to provide a small, appropriate buffer between tasks, allowing recovery from routine disruptions to a single operation without affecting the overall system throughput. Thus, overall uptime would never be substantially worse than any individual system. Also, the total production volume would be divided between 3 identical systems. In this way, if there were a significant problem with one system, 2 others would still be producing. With the project parameters in place, the partnership turned their sights toward actual production of the new system. The new welding system utilizes a production platform known as the Genesis Versus System 4M Robotic Welder.
The product that we put forward for the application is based on our Versus System 4M, and it's a Ferris wheel style positioner, single point load and unload, so the operator's loading and unloading while the robots are welding, and the axle actually moves down the line progressively and is assembled as it goes along in a kind of a decoupled manufacturing operation. Beyond that, our client had specific needs for and specific manufacturing goals for a lot of operator flexibility and a very solid, robust robotic welding work cell. So we did quite a bit of work on controls that make the system, one system to the other, being similar in operation, so operators have some flexibility moving from one work cell to the other. But it's all based on the Versus System 4M work platform with its single load and unload point, and then customized to some level with controls that are suited to the application.
Not only was the weld system designed to meet AAM's demanding production requirements, it also incorporated several features which helped to prevent downtime. Uptime-oriented features sense if a part is present and whether or not the part is clamped down. A graphic display provides an easy-to-use interface that monitors important system functions. The interface also guides the operator through error recovery and routine maintenance procedures, and allows the operator to control the system when it is not running in auto mode. With the new part design maturing, the variation simulation analysis confirmed manufacturability of the design. The total concept was run through a series of vigorous testing simulations. The new welding system performed perfectly. It was time to put the planning and testing into practice. Genesis was holding up to the challenge AAM presented.
The 25-day run at rate is where the equipment proved that it was capable of operating with in excess of a 92% uptime and at rate and at the dimensional requirements for the product. So they wouldn't accept the equipment until it had performed for 25 days in production, making a part every 30 seconds at better than a 92% uptime and with all dimensions in spec.
Over the next 3.5 weeks, the system ran at production with an uptime of greater than 95%. The system had performed above specifications, achieving the optimum balance of speed and quality. After 25 days, the runoff was complete, and AAM had its product complete.
The real magic is trying to capture the variabilities that enter into the process, and the variabilities come from working real closely with your client, trying to figure out, okay, how are the primary parts made, the simple parts that come into a weldment configured, what are the tolerances that are associated with those, how does the design work? And oftentimes we'll find that we take a look at a project and we think, rather than purchase a robotic welding system, the effort ought to be expended on the design process. And we'll say, hey, we're dying to talk to you, we're dying to work with you, but let's wait a year. Let's concentrate on the design, and if we work on that, we think you'll have a much happier situation with your robotic welding system, and it's going to be a lot more reliable for you too.